This is a video from the Chapter 9 review. We're going to look at 22a. Suppose we're given dx dt is equal to 1 minus t plus x minus tx. So we're going to factor the right side of this differential equation by grouping. And so what we can say is that dx dt is equal to 1 times 1 minus t plus x times 1 minus t. So dx dt is 1 minus t times 1 plus x. This is a separable differential equation. And so notice how dx dt is a function of t times a function of x. So the next line, we can say 1 over 1 plus x dx is equal to 1 minus t dt. And I want an explicit solution to this differential equation for full credit. So the integral of 1 over 1 plus x dx is equal to the integral of 1 minus t dt. So natural log of the absolute value of 1 plus x is equal to t minus 1/2 t squared plus c. So the absolute value of 1 plus x is equal to e raised to the t minus 1/2 t squared plus c. So the absolute value of 1 plus x is equal to e to the c times e to the t minus 1/2 t squared. That's just laws of exponents to go from here to here. So 1 plus x is equal to plus or minus e to the c times e to the t minus 1/2 t squared. And what I did was I let a equal plus or minus e to the c. And so therefore x is equal to negative 1 plus a e to the t minus 1/2 t squared. So this is an explicit solution to the first differential equation. 22b. X squared dy dx minus y is equal to 2x cubed e to the negative 1 over x. Now, this is a first order linear differential equation. And so what I need to do to solve this is divide through by x squared. So dy dx minus dy dx minus 1 over x squared y is equal to 2x e to the negative 1 over x. So my integrating factor is e to the integral of negative 1 over x squared dx. But that's e to the integral of negative x to the negative 2 dx. And so therefore I is e to the 1 over x. That's my integrating factor. And so what I want to do is I want to take this differential equation and I want to multiply through by e to the 1 over x. So e to the 1 over x dy dx minus 1 over x squared e to the 1 over xy is equal to 2x e to the negative 1 over x times e to the 1 over x. But remember, laws of exponents. A to the negative m times a to the m is equal to a to the 0. Negative m plus m is 0, and that's 1. And so when I multiply these two guys together, I get 1. And also remember that the derivative of e to the 1 over x is negative 1 over x squared e to the 1 over x. And so the derivative of e to the 1 over xy is equal to 2x. That's what this line says. So e to the 1 over xy is the integral of 2x dx. So e to the 1 over xy is x squared plus c. And we're almost done. That says y is x squared e to the negative 1 over x plus ce to the negative 1 over x. That's 22b. 22c. 2ye to the y squared dy dx is equal to 2x plus 3 root x. This is a separable differential equation, so we can rewrite this over here as 2ye to the y squared dy is equal to 2x plus 3 squared root of x dx. Integrate both sides. The integral of 2ye to the y squared dy is equal to the integral of 2x plus 3 root x dx. Okay, from here, we can say e to the y squared is equal to x squared plus 3 times 2/3 x to the 3 halves plus c. 3's cancel. And so y squared is equal to natural log of x squared plus 2x e to the 3 halves plus c. And so therefore y is plus or minus the square root of natural log of x squared plus 2x to the 3 halves plus c. And that's how you do 22c. Now, in this video, we can take a look at 23a. In 23a, we have du dt is 2t plus secant squared t divided by 2u. And we have an initial condition, and it says u of 0 equals -5. We need an explicit solution to this differential equation that satisfies this given initial condition. And what this says is when t is 0, u is -5, right? And so 2u du is equal to 2t plus secant squared t dt. If I integrate both sides, the integral of 2u du is the integral of 2t plus secant squared t dt. So u squared is t squared plus tangent t plus c. Now, I'm going to plug in my information so that I can solve for c. So, -5 squared equals 0 squared plus tangent of 0 plus c. But what this tells me is that c is 25. But we're not quite done. So now, u squared equals t squared plus tangent t plus 25. But then what is u? Remember, u of 0 is -5. So when I take the square root of both sides, u, it turns out to be negative the square root of t squared plus tangent t plus 25. So it's a little tricky because you have to take the negative radical. And that's how we do 23a. 23b. Suppose 1 plus cosine x dy dx equals 1 plus e to the negative y sine of x, and y of 0 is 0. Okay, from here, I'm gonna say 1 over 1 plus e to the negative y dy. This is separable, okay? So what I did was I divided both sides by 1 plus e to the negative y. Now, on the other side, this is sine of x divided by 1 plus cosine x dx. So you can think of it this way. I divided both sides by 1 plus cosine x, and then multiplied, quote unquote, by dx. Okay. Now from here, on the left-hand side, I'm going to multiply numerator and denominator by e to the y. So it's a little easier, I claim. So we get e to the y over e to the y plus 1 dy. That's the left side. The right side is sine x over 1 plus cosine x dx. Integrate. So e to the y over e to the y plus 1 dy. The integral is the integral of sine of x over 1 plus cosine x dx. So natural log of e to the y plus 1. That's the left side. The right side is negative natural log of the absolute value of 1 plus cosine x plus some constant c. I don't have to put absolute value bars around 1 plus e to the y because it's always positive. Now, when x is 0, y is 0. Okay? So what does that mean? That means natural log of 2, that's the left side, is negative natural log of cosine of 0 is 1, 1 plus 1 is 2. So we get negative natural log of 2 plus c. C is 2 times natural log of 2. And we can say the following. Natural log of 1 plus e to the y is negative natural log of the absolute value of 1 plus cosine x plus 2 times natural log of 2. And then if you guys have a question, right, from here, I want to ask you, how would I solve for y? So I will leave that as an exercise. How would I get y by itself? That's a good question. Let's take a look at 23c. So x dy dx minus y equals x times natural log of x. And then y of 1 is 2. So dy dx minus 1 over xy is natural log of x. So you can see this is a first order linear differential equation. So my integrating factor is e to the integral of negative 1 over x dx, which is e to the negative natural log of x, and that's 1 over x. So 1 over x dy dx minus 1 over x squared y is 1 over x times ln x. Now notice, The derivative of 1 over x is negative 1 over x squared. The derivative of y with respect to x is dy dx. So this is the product rule backwards. And so we get 1 over xy prime is 1 over x times the natural log of x. So 1 over xy is the integral of 1 over x times ln x dx. So 1 over xy is 1/2 of natural log of x squared plus c. Now, when x is 1, y is 2. So 1 over 1 times 2 is 1/2 of natural log of 1 squared plus c. But remember, natural log of 1 is 0. So c is 2. This is really good. So 1 over xy is 1/2 of ln x squared plus 2. It's a specific solution to this differential equation. So y is 1/2 x times natural log of x squared plus 2x. And that'll conclude this video. We did problems 22A, B, C, and 23A, B, and C. Thank you.